Hi there, welcome to the lab. Today we're going to have a look at what should be a Mastfuyi FY106B digital multimeter. I did get this multimeter from AliExpress with my own funds, and so I'd like to just ask that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Your questions and comments are always welcome, the feedback is appreciated, and it helps me figure out where to focus my activity. Let's get into the box. A little crushed in shipping there. So it's a very kind of compact unit. There's a manual here. The manual has several languages: English, German, Deutsch, Francais, Espanol, Italiano. So 5 languages, and about 16 pages or so are in English. So we'll just put that to the side for now. And then in the bubble wrap here, we've got the meter. So that's the meter. And then there's a set of probes. And so these probes have straight plugs as opposed to right angle connectors because they slot in here to the bottom. And we'll have to have a look at, they slot in nicely. So not a lot of resistance there or force required, so that's good. And there's a little sticker here which says that we shouldn't have the probe plugged in here if we're measuring voltage. So this is usually where we measure current. In most multimeters, that's a convention. And we don't want to put the probe in there when we're measuring voltage because that'll blow the fuse. Usually a bad idea. The probes, sort of a standard PVC. And they've got these covers on them. Yeah, they're somewhat sharp. They're sort of the smaller style of probes, so compact probes. They feel okay. Yeah, they're fine. And now let's have a look at getting the batteries into the unit. I've got the battery compartment open here, and so we can see that it takes 2 AAA batteries. We also see a nice brass retention ring. The screw doesn't have a retainer, so you need to make sure that that doesn't get lost. I'm just going to put the batteries in and we'll close up the unit. Okay, there we go, and it's turned on for us. Let's power it up and have a quick look at the features. One of the sort of selling points of this particular unit is the display. And so we can see it's a very nice looking display. Very nice, bright, sharp. And in terms of the functionality here, well, we've got the power button. We've got the mode selection. And I think there's a light there. Oh, there is. Look at that. There's a light at the end. When the unit's powered on, it starts out in auto mode, and then with the select button, we move through, that's DC voltage, AC voltage, frequency, resistance, continuity, diode check, capacitance, and then DC current and AC current, and then back to auto. Now, a quick look at auto mode. If you've seen some of my other videos, you know that I'm not the biggest fan of auto because it has some confusion, especially around low voltage and resistances. But let's just have a quick look here. So right now, the calibrator is set to output 0 volts, but we're not connected. Let's plug it in, and let's see what it reads first. And so at the low voltage setting, it is seeing that as a resistance, and so it thinks that it's continuity, and as a result the beep is going off. Let's bump the voltage up. So at 1/10 of a volt, now it's seeing that as a resistance, but enough of a resistance that the meter doesn't go off at all. And then 0.2 of a volt, still resistance. 0.3 of a volt, still resistance. 0.4 of a volt, resistance. Half a volt, back to auto. 0.6 of a volt, still in auto. 7, 8, 9, 1 volt. Okay. So now that's showing about 1 volt. 0.9, come down, that's showing okay. 0.8, no. So around 0.9 volt, around 1 volt, you can see we're off just by a hair, so that's a good reading there. But we have to get up to about 0.9 volts or 1 volt for auto in order to kick in and see that as a voltage. Now let's, on the flip side, try resistance. I'll just unplug that. So now we're set for 20 ohms. We plug that in. It is seeing 20 ohms, but once again, because it also does double duty as continuity, we're hearing the continuity buzzer. If we go to 30, 40, 50, 60. So usually between 50 and 60 ohms is when the units decide that it's not closed circuit, if you will. And so the buzzer is turned off and we're showing 60 ohms or pretty close to 60 ohms, a fairly decent reading. And so that's how auto works. And that's one of the reasons, as you can see, that I'm not really a big fan of auto if you have to measure anything that's a low voltage or a low resistance, because it's I find it just frustrating to use. Now looking at DC voltage directly, so I put the unit into the dedicated DC voltage mode. And there's a little bit of noise that you can see until I connect. So I'm going to just connect the lead here. And so now we're showing 0, which is what we expect, and no weird behavior. 0.1 of a volt. It's off by just a touch, so that's a pretty decent reading. 0.2 of a volt, total agreement there. We'll go up to 0.5 a volt. Pretty good. And then we'll go to 1 volt. Same as what we saw from auto. We'll go to 5 volts. And so we see 499. That's still pretty good. 10 volts. 999 once again. So just a touch off in the last digit. So very, very good performance in terms of voltage accuracy. For AC voltage, I use this Bryman as a bit of a reference point to compare to the meter that I'm testing out. And so right now I'm plugged in, the power's off, so we're seeing a little bit of ghost voltage appear between the two units, and they're pretty much the same. Let's turn the power on. And so now we're seeing 122.9, 122.34. So there's a difference of about, looks like it's about 0.4, 0.5 of a volt. We'll do that one more time. The ghost voltage, and now the voltage. And it does look like it's about 0.5 a volt of discrepancy between the Mastfuyi and the Bryman. Now we're going to have a look at the current. So I've plugged the leads in on the current side, and we'll move this to, this is DC current mode. Now the calibrator can only put out milliamps. Right now it's 0. This is showing 0. We'll plug it in, and that's good. Now I'm just going to move that up. That's 1 milliamp. That should show up in the end here. Not yet, I guess. 2, 3, 4, 5, 10. Okay, so now 10 milliamps is showing up. So 9 milliamps isn't showing up. So 10 milliamps shows up. Okay, 11, no. 12, it's off a bit. 13, okay, so it's off by a milliamp. 14, that's good. And then we'll go up 16, good. 20, that's good. And 24 is where this maxes out. And so that's good. So milliamp looks like it works reasonably well, except that it won't sense below 10 milliamps. So we have to have at least 10 milliamps to register, which is a little bit non-intuitive given that it is showing the digit here, the last digit for milliamps. Now I'm set up for AC current. I've got an AC fan here. The Bryman is in AC current mode. The Mastfuyi is in AC current mode. Everything is ready to go. I'm going to turn the power on. And we can see a high current draw as the fan starts up to speed. And then once it settles in, we're showing 170 milliamps on the Bryman, 169 now, and you can see pretty much 169 milliamps as well on the Mastfuyi. Sometimes there might be a little bit of variance. So very good agreement between the two, and so nice performance in the AC current mode. Now looking at resistance, we're not connected yet. The calibrator is going to put out 20 ohms, plug it in, 20.1, so that's a decent reading. We'll go up to 50 ohms. Oh, look at that, 50, bang on, very good reading. 100 ohms, excellent, bang on. Let's go to 500. So now that's switched over and it's 0.499k ohms, so off just by a touch in the last digit. We'll go to 1k. That's 1k, perfect reading. Actually, I love the accuracy on this unit. And then we'll go up to 2k. Once again, off just a touch in the last digit. So very nice performance in the resistance mode here. Looking at frequency, I've put the Mastfuyi into the frequency mode. The calibrator is set to output a 0.1 kilohertz or a 100 hertz signal. And if we connect here, we don't see anything. The calibrator outputs a square wave signal, and it could be that the Mastfuyi, like a lot of other meters, unfortunately, is only able to discern sine waves. And you can see as I take the frequency up here, there's nothing registering here. So it's not able to assess the frequency of the square wave signal that the calibrator produces. I'll just use the AC line here to test the sine wave measurement. And that's into the neutral. I'm going to plug in the live wire, and we can see that now that's measuring 60.1 hertz. And if I unplug, it takes a while, but it does settle back down to 0. For capacitance, I've got a reference board. The calibrated values are up in the overlay. I will call out the base values as we go through them. So starting with the first one here at 100 picofarads, that's a very good reading. This is 1 nanofarad, also a good reading. This is 10 nanofarads, pretty good reading. 100 nanofarads. Wow, that is a fantastic reading. This is 1,000 nanofarads. So that's a little bit low. And then 10 microfarads. That's also a pretty decent reading. Wow, well that's excellent performance in capacitance mode. Now diode check, I've got the test box here. Let's see how we do. And the Mastfuyi's in dedicated diode mode. So that's a good reading. That's a good reading. Diode lights, just barely. And that doesn't light, and that doesn't light. So I expect that the test voltage is capped at about 2 volts. given that. And okay, so that's a good reading. So there's no tone produced for the valid diodes or for the short circuit. Now I place the unit into the dedicated continuity mode. You can see that there. And we'll just do the standard tapping test. So brief taps don't work, but a lengthy tap works. Now that's with the stock probes. I'm now going to switch over to a set of gold-tipped probes. So I've got these gold-plated probes here, and now I mean, you can see once in a while it misses something, but much better performance in continuity with the gold-plated probes. Now non-contact voltage, let's put the meter into non-contact voltage mode. I have this plug, and this is the hot line, and I test by bringing the hot line in proximity to where the sensor is usually located, which is at the top. So let's see how that goes. Oh, that's good. We're seeing that's about a centimeter, a little over a centimeter out, and strong performance even before the plug is in contact with the surface. So that's very good performance for non-contact voltage in terms of sensitivity. Most meters don't give me a strong reaction like that until the plug is right on top of the unit. Now, live wire detection. I should be able to do live wire detection by plugging the probe in here, and then this is the hot line, ground, neutral. So no response there on ground expected, no response there on neutral expected, and also no response there on the hot line, which is not expected. But now look at this. If I pick up the unit, we see a response there, which is good. There, no response there, which is good. And you might say, oh, well, you know, maybe that's because I've turned into a path to ground or something like that. But let's do something else. I'll just plug in the line here. And so that plug is sitting there. Now, I don't think that's a path to ground. And I'll plug this in. Ground, no problem. Hot line, active. So this is a behavior I've seen in a couple of other meters where even though the unit should operate without having anything plugged in on the common line, it requires something plugged in or you have to be holding it in your hand. Quick look inside now. There's 4 screws and then the top just comes off. The battery is spring contacts, and so we don't have any wires to worry about when separating the case. So now if we bring this up here, what do we see? Well, the first thing that I always notice is that they really don't want us to know what specific DMM control chip they're using here. Given the number of components on the board, what we don't see here, which means it's all integrated in here, there's sort of the DMM functionality, there's the LCD controller in here, and there's probably also some flash memory in here for storing at least the calibration information, if not some additional configuration info that might be there. Now we also see here there's a fuse. Of course, this is fuse. Now this meter goes up to 4 amps, so not 10 amps like a lot of systems, but that fuse is there. There's a PTC here, so further input protection. There's a small relay here, and so we see that small relay in systems, in multimeters like this, that are using soft buttons rather than a physical switch, because it is necessary to switch some of the input lines that are used for some of the modes, and so you can't use the input lines for all the different measurements on the chip, and so you have to sort of switch the input lines and this relay is used to do that, to get onto the right inputs for some of the modes. The buzzer here, we've got the light here for the LED, and the spring contacts for the battery. These are the backlight connections for the display. And then we can see here, this is, and it's maybe hard to pick out, but we can see the antenna that's used for non-contact voltage. And so it's fairly long, and it stretches across the entire top end of the meter. And that probably explains why the non-contact voltage performance is so fantastic in this unit. Nice long antenna, and it's not sort of a flimsy little point or something. Sometimes they kind of put a big sort of plane into the circuit board itself. So this is kind of a nice to see thing. It really exposes a lot of, let's say, antenna area, if you will, to sense the current field. And so that's a nice thing to see in the design. And aside from that, there's not much else to see here. I mean, we see the input connections and stuff. But because of the high amount of integration here on the chip, there's just a little bit of additional support functionality needed to essentially get this all operational. This is a nice compact meter with a bright backlit display. Measurement accuracy was generally good. Capacitance accuracy was amongst the best I have seen. Non-contact voltage also performed extremely well. Current up to 4 amps can be measured with input protection via a fuse and a PTC. It does have the usual shortcomings of auto mode, where low voltages and resistances can't be measured effectively. Fortunately, there are dedicated modes for all the properties that can be measured via auto mode, so this is not a showstopper. There are a few deficiencies to take note of. Live wire detection didn't work as expected and as described in the manual. Frequency measurement did not detect a square wave signal, and DC current below 10 milliamps did not register and cannot be measured. The excellent non-contact voltage performance would make this a good choice for casual home use, but the live wire behavior diminishes the value of this strength. If you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Thanks for watching, and until next time.